All right, telecom execs, technocrats, and investors, let's jump right in. Today, we're breaking down the OJAS Structural Intelligence Framework. Think of it as a rigorous mathematical architecture for automating your Wi-Fi networks.
Okay, let's dive into this. The massive elephant in the room? Automated systems trying to fix bad Wi-Fi usually just drop your most valuable customers so their network health scores look pretty. So how do we actually fix the network without kicking off the good users?
Here's our roadmap. We'll be quickly covering the public Wi-Fi problem, how to protect meaningful traffic, the structural framework itself, network safety, governance, and finally, total auditability. Starting off with Section 1, the flawed status quo of public Wi-Fi. The old way of managing this is basically whack-a-mole, chasing arbitrary metrics by suppressing traffic. But the new OJAS way is a real game changer. It uses surgical, tonnage-weighted intervention to protect your meaningful traffic while completely ignoring the simple passersby. Moving to Section 2, protecting that meaningful traffic using tonnage and topology. The math here literally treats your network like a giant graph. It measures something called Dirichlet energy, which is essentially the total incoherence of your access points, weighted by the actual valuable traffic. The whole goal? Minimize that chaos. Section 3, mapping that heavy math directly to Wi-Fi. Now, what's really interesting about this is how established math operators bind directly to concrete Wi-Fi mechanisms. Operator A handles profile clustering, Operator C sniffs out transient clients, and Operator E, it calculates the absolute minimum intervention needed to fix an issue. Section 4, protecting the live network through control theory. Because let's face it, nobody wants an AI breaking their live network. So strict safety rules are hard-coded into the math. Zero profile flapping, strict minimum hold times, and absolutely no deauthentication loops. It mathematically guarantees stable changes. Safety here isn't just a configuration toggle someone can accidentally turn off. It's enforced as a mathematical theorem. The system operates in a strict allowed action set, meaning forbidden, risky actions simply cannot be executed. Section 5, the governance model, using health indices. Every single recommendation gets governed by its structural health index score. Green band applies automatically, amber mandates human review, and black, it completely halts everything for manual investigation. And if the system gets conflicting data, it safely abstains. That's not a failure. That's a principled, certified decision not to act, routing the issue for review rather than risking your network. Section 6, auditability and proof via the 12-tuple receipt. The framework uses what we call proof-carrying computation. What that means for you is every automated fix comes with a categorical receipt. You get auditable, mathematical evidence proving it was exactly the right call. This 12-part receipt is the real deal. It guarantees spectral reliability, preserves user privacy with zero-knowledge proofs, and perfectly tracks the exact provenance of all telemetry. Crucially, it validates actual commercial impact by using conditional independence to rule out confounding variables, like time-of-day traffic shifts. The math mathematically proves the exact before and after ROI on your network. So I'll leave you with this. Does your current network AI actually solve problems, or does it just hide them by dropping your most valuable users? OJAS proves that rigorous math can optimize your network while fiercely protecting the traffic that actually matters.